In this video, I'm going to be covering the difference between a strong and a weak acid based on how much they want to donate their hydrogen. So with a strong or a weak acid, we can denote either one simply as HA. This hydrogen is the hydrogen that either one of these acids want to donate. Now, the difference between them is how much they want to donate that hydrogen. A strong acid reacts 100% yield, meaning when we have a situation where we have a strong acid and there is base around, this acid will always donate its hydrogen. So we saw in the last video how when an acid will donate its hydrogen, we'll be left with A minus. Those electrons from that bond will stay on the A. So if we were in a situation where we had 1 molar concentration of HA, if we had enough base to accept all of those hydrogens, we'd be left with 0 HA and all A minus. We will always donate that hydrogen if we are dealing with a strong acid. Now, a weak acid, we can simply say it is not 100% yield. In fact, it is often much, much less than 100% yield. For a weak acid, we are not going to see anywhere near all of the hydrogens be donated. So we can just say not going to donate its hydrogen every time. So the same thing will happen with a weak acid. HA will go to A minus when we donate this hydrogen, but if we started with 1 molar concentration of HA, we would have to know a little bit more to the story, which I will go into in the next couple of videos for a weak acid, how much of that acid we will be left over with and how much of that A minus will be left over with. So the main difference here is that a strong acid always donates its hydrogen to any base that will accept it, and a weak acid is not going to do that 100% of the time. We need to know a little bit more of the story, but understanding this is super important because when we do problems with having to know how much of something we have left and how much of something we produced, we need to know whether we're working with a strong or a weak acid.